In this video, we're going to look at the Aldol condensation. Let's jump right in. We've seen previously that carbonyl compounds, the carbon right next door to the carbonyl compounds, the alpha carbon, has very acidic hydrogens. So a base like hydroxide, or there's another one common in these reactions called LDA. A base can pull off this proton, leave the electrons behind, and make this compound. So this negative carbon, this is called an enolate. And I have a previous video which explains all of this. This enolate is an aggressive nucleophile. It wants to go attack something. But we have gazillions of these molecules in there. And as soon as one of these nucleophilic attackers is in there, we have another one of these molecules. Let me draw it. Right, there's billions and trillions of those around. This is on the hunt for something. This negative wants to attack a positive on this compound. Where is the most positive spot? Well, of course, it's the carbonyl carbon. So I attack that carbon. The electrons go up to the oxygen. Do they come back down? Well, this is a bad leaving group. This is a bad leaving group because they're carbon groups. So those electrons stay up on the oxygen. So I make this. I have methyl, carbonyl, CH2, bonded to this carbon with an O- at the top, and it has two methyl groups on it, this one and this one. And this molecule stays like this until I quench with acid and water. The negative oxygen grabs the H plus to make CH3, C double bond O, CH, H, C, there's an OH now there, and my two methyl groups. Now sometimes this molecule stays like this, and you have an OH and an H. Sometimes what happens is called a dehydration, which means it loses water. Oh, and that's why sometimes this aldol, let me spell that correctly, that's why this is called an aldol condensation, because we make water. So aldol condensation, so we lose water. So that means this hydrogen and this OH group fall off to make a double bond right here. So we have CH3, C double bond O, CH double bond to a C with two methyls still on it. Let me pause to clarify something at this point. When we lose water, I'm going to pull off this OH group. This is the only one on the entire molecule. And I need to pull off a hydrogen from a neighboring carbon. But how do I know which one? Well, let's see what we make when we pull off three different hydrogens. If I pull off this hydrogen atom, then I'll make a double bond right here. So I would have CH3, carbonyl, CH2, carbon with a CH3 on it, double bonded to a carbon with two hydrogens. If I pulled off a hydrogen on this neighboring carbon, so there's the carbon with the OH, here's a neighboring carbon, then I get a double bond here. In that case, I get CH3, C double bond O, CH2, carbon, double bonded to a carbon with two hydrogens. And this CH3 is still on that carbon. If I pulled off one of these hydrogens to lose water, I'll make a double bond here. CH3, C double bond O, carbon with one hydrogen, double bonded to a carbon with two methyl groups. Those are the three possibilities. But I like this one the best. And it's because it is conjugated. Now in organic chemistry, when you can get a double, single, double situation, a double bond, single bond, double bond, that's called a conjugated system. And we'll find that they're lower in energy than systems that are not double, single, double. In this case, I have a double and then two singles and then a double. Double, single, single, double. That's not as good. Here I have a double, a single before I get to my double again. That's not as good. So with the carbonyl pi bond being there, this double bond, I like this one that's conjugated. Double, single, double. So we lose the hydrogen atom that's between the OH and the carbonyl. That's the one we pull off. So I can get a double bond at the position that makes it conjugated. Now, since water fell off, let me show you a little trick. You can take a little card that has double bond O and two hydrogens on it, and let me show you if I put H2O back on. So I'm going to go to this double bond right here, and I'm going to put that over top of one side of the double bond, and I can see the acetone I started with, methyl, carbon, methyl, carbonyl. Or if I take the other side of that double bond and I put my two hydrogens on it, I can see methyl, carbonyl, methyl as well. So my molecule that I started with, I can see in the final product. If you don't have a card with you, you can just cover up that double bond, one half of it, and see methyl, carbonyl, methyl. And you can cover up the other side if my hand was an oxygen, methyl, carbonyl, methyl. So that's a good way to double check if you have the final correct product for the aldol condensation. Now, this is the mechanism through the entire thing to get to the final product. But let me show you how to jump to the answer a little faster. So if I'm doing an aldol condensation with these two molecules with some base, followed by dehydration, let's jump to the final answer. So the best way to do that is just to take this molecule and redraw it. But we're going to take off an oxygen and two hydrogens, that water we lose, as we go along. So I'm going to pretend like I'm drawing this, but I'm going to stop and erase that oxygen. Now I need to erase two hydrogens off of the other molecule. Well, we know that the alpha carbon is where the two hydrogens are. So I'm going to redraw this, but I'm going to draw this carbon right here, take off two of its hydrogens and just leave one behind, and then I can draw the rest of this. And this is the final product, starting with these two compounds of an aldol condensation. Let's double check. We'll cover up. If this was an oxygen, yep, I see that molecule. And if that was two hydrogens, yep, I see that molecule. So I think I made it. All right, let's do it again with a brand new molecule. Let's take a phenyl, C double bond O, CH3. So of course we have a whole bunch of those, so I'll draw another one of these. Some base. And let's see if we can just draw the final product. So let's take this. Erase the oxygen. I'm going to erase these two hydrogens and just put one in. This is my alpha carbon. How did I know it was this carbon and not this one? Well, this carbon has no hydrogens on it, so it must be these two. So then I draw my carbonyl, and my phenyl is still on there. And that would be the final product. Do a quick double check. Yep, I see that. And yep, I see that. I'm good. Let's do another one. Let's take these aldehyde compounds and try to figure it out. Well, this side does not have an alpha carbon, but this side does. So this must be where I remove the protons. Let's just try to jump to the final product. So I redraw this, remove the oxygen. Now I need to put this carbon, the alpha carbon, right above here. So that's this carbon. There were two hydrogens there. I'll remove those two hydrogens. So that's still on that side. And on this side I have a carbonyl hydrogen. We'll do my little cover-up test to see. Yep, that's that product. And that's that product. Good, I made it. Now let's try to work backwards. Let me give you a final product, and let's see if we can figure out what molecule we started with. So if somebody were to say, how can you make this molecule using an aldol condensation? What would you start with? Well, we'll need some kind of base. And let's see if we can figure out what molecule was used. So there's my carbonyl. Here's the double bond where the dehydration occurred. And what I need to do is say, well, if I cover up half of it and put an oxygen in, it looks like that would be my starting material. Let's go to the other side of that double bond and put my 2 hydrogens in. And do I get the same thing? Terbutyl, carbonyl, CH3? Yes. So this molecule, or beaker full of a bunch of these molecules, and some base, like hydroxide. So somebody might write sodium hydroxide, or somebody might write potassium hydroxide. So one of these hydroxide bases with this would give me this final product. So it's good to practice going forwards and backwards in an aldol condensation until you become very comfortable with it. Hey, I hope that helps. Think about subscribing to the channel so I can help you more with your organic chemistry.